In the European Union, it is estimated that standby power, also known as vampire power, accounts for about 10% of the electricity use in homes and offices of its member states. This will rise to 49 terawatt-hours per year, nearly equivalent to the annual electricity consumption for Austria, Czech Republic and Portugal combined. How much more pressure will be on the grid as consumers purchase more mobile phones and business and governments acquire more supercomputers to make sense of all the data they are collecting? The numbers are staggering, but there is hope. Today, the European Union has announced a new project consortium called STEPA, made up of corporate R&D labs, including IBM and several universities in Italy, Switzerland and Germany, that are tackling this huge challenge at its smallest element, the transistor. During the next 36 months, scientists in the consortium will combine their collective know-how on tunnel field effect transistors and semiconducting nanowires to significantly reduce the power consumption of the basic building blocks of integrated circuits in the smallest consumer electronics and massive supercomputers. To explain the challenge, consider a leaky water faucet. Even after closing the valve as far as possible, water continues to drip. This is similar to today's transistor, in that energy is constantly leaking or being lost or wasted in the off state. In STEPA, scientists not only hope to contain the leak, but also open and close the gate for maximum current flow with less turns. Scientists believe they can reduce power consumption in electronic devices when they are in use by a factor of 10. Even more amazing is that they believe they can reduce the power consumption to nearly zero when these same devices are in standby or sleep mode. This means cheaper electric bills and longer battery life for laptops, cameras and mobile phones. To achieve this, scientists will study the development of so-called tunnel field effect transistors based on silicon, silicon germanium and 3,5 semiconducting nanowires. The project started in June 2010 and will continue for 36 months. This is Anne-Marie Cromack reporting.